Welcome to Maths Classes 7-8 CBSE by GK Pillai. Let me tell you about my videos. My videos are strictly based on new syllabus of classes 7 and 8. Since I have been teaching students for long years from previous textbooks and aware of some schools using reference books from private publishers, I have been including extra practice questions to cater to these needs. Any student who has done extra questions in the school can practice these questions and gain some extra knowledge. Students and parents, subscribe to my channel and encourage others also to watch these very useful videos. You can offer your comments and your suggestions for improvement if any in the comment box below my video. This chapter, by name Finding the Unknown, is about algebraic equations, how to form equations and how to solve them. Before learning about equations, you should recall what are algebraic expressions, how they are formed, how they can be combined and how it can be used. There is a difference between algebraic expression and algebraic equations. Let me discuss about algebraic expressions. Mathematical expressions containing letter numbers, such as the expression y plus 7, are called algebraic expressions. Now letters such as p and q that are used to represent numbers are called letter numbers. Here y is the letter number. Or variables. We used to call the letter number as variables in the previous textbook. What we do to get the algebraic expressions, we combine letter numbers, the one I just discussed. It can be x, y, p, q, even m and n. And constants like 4, 100, minus 7, etc. These are actually numbers. And use addition, subtraction, etc. to make algebraic expressions. Here y is a variable or letter number. 7 is constant. By using the addition sign, we get this. This is the simplest algebraic expression, the very easiest one. Now another thing you should know, a letter number can take any value. This is what we do in algebraic equations. Its value is not fixed. But a constant has a fixed value since these are numbers. Here you will get some examples of algebraic expressions. I have just explained about algebraic expressions. When we equate two algebraic expressions or one algebraic expression with another constant term, we get equations. The statement goes this way. The statement of equality between two algebraic expressions is called an equation. There is an alternate definition also. An algebraic equation is a mathematical statement that indicates the equality of two algebraic expressions. So both will be okay. One of the two you can understand and learn. Nowadays we write an equation as two algebraic expressions with an equal sign between them. Now there are some examples given here. Here the variable or the letter number is on the left hand side. Here it is on the right hand side and the constant term is here. Here the constant term is a denominator. Here there are two letter numbers on two sides. These are different examples of equations. Solving an equation. You can see the definitions here. This is a bit longer one and this is a smaller one. Both are from your textbooks only. The process of finding the value of the letter numbers or the variables for which the equality holds. This is the first part of this definition. So you can find the value of the letter number so that the equation remains or the equality remains, or for which the value of the left hand side of the equation becomes equal to the right hand side of the equation. This is called solving the equation. It is the same thing. The first part, whatever is written in the first part, is the same as the second part. Ultimately, when you do the solving part of an equation, you will get the value of the unknown so that the left side will be equal to the right hand side of the given equation. Here it's a very simple definition. This is the theoretical one and this is the practical one. Equations can often be solved by performing the same operation on both the sides so that the value of the unknown becomes evident. This you will be able to understand better when we do the sums. Here there is another term called solving equations systematically. This is also a term, this is also a heading given in your textbook only. One way to solve an equation is to substitute different values in place of the letter number and to check which value makes LHS equal to RHS. This is not at all an important one because the trial and error method we don't normally use for solving the equations. There is an example given here. 3p plus 1 equal to 64. This is an equation and you have to get the value of the unknown p. What we do according to this method, trial and error method, and according to whatever is given here, we have to substitute different values at the place in the place of p and see whether the LHS becomes equal to RHS. First, let us substitute p equal to 5. 3 into 5 plus 1 will be 16. You keep on putting different values so that the LHS equal to RHS. Finally, when you put p equal to 21 in the place of p, if you put 21, then only this will become equal to 64. And this method is called trial and error method. This method cannot be used efficiently, so that is why we don't attach much importance to this one. I can just tell you one. This is a textbook question only. Try solving 5x minus 4 equal to 7 using trial and error method. If you substitute 1 here, 5 into 1, 5, 5 minus 4, 1. So the LHS is not equal to RHS. If you put 2, 5 2s are 10, 10 minus 4, 6. No. 5 into 3, 15, 15 minus 4, 11. It's not becoming. The LHS is not equal to RHS. So you have to keep on putting different values so that it becomes equal to the LHS becomes equal to the RHS. That is called the trial and error method. In the textbook, you will find examples 1, 2, 3 and 4. These are meant to explain you a particular method of solving the equations. In the textbook, you will find the bigger values. Here I am using smaller values to explain the concept. 89 minus 25 plus 45 minus 27 plus 58 will give you 150. What is the value of 89 minus 25 plus 45 minus 27? So this excludes 58. According to them, instead of finding the value of all, you can subtract 58 from 150 so that you get the value of this. The same way, 18 into 13 into 16 into 7 into 6 will give you this. And what is the value of the expression? This 18 into 13 into 16 into 7. Once again, you can get the value of this by dividing this number by 6. Let me tell you one more thing. In the initial part of the textbook, initial part of the chapter in the textbook, There are some figures where unknown weights are on one side and in some cases, in some figures, on both the sides. These figures are meant for explaining you the concept of equations where the LHS should be equal to RHS. Sometimes equality can be maintained or achieved by removing equal weights from both the sides. This is what is explained in your textbook in this part, in the beginning of the textbook. What I am doing, I am giving below only the equations in the case of figures 7.6 to 7.11 by using letter numbers or variables to denote the unknown weights in these figures. These two questions or equations are identical to your textbook examples. The step-by-step method of solving equations is explained here. Later on you will find the sums with reduced steps. The first one, solve the equation, these two. The first one here, 17y plus minus 4 equal to 81. The first step is to take this minus 4 to the other side, subtracting minus 4 from both the sides. So this will be plus minus 4 will be there. We will be writing additionally minus of minus 4 on both the sides. Now these two get cancelled. You will get 17y equal to 81 plus 4. Minus into minus plus. 17y equal to 85. Now dividing both the sides by 17. The idea is to bring this 17 as a divisor here. 17y divided by 17 equal to 85 divided by 17. 17 and 17 gone. You will get y equal to 5. So y equal to 5 is the solution. The next one, we have got variables on both the sides. Our first aim is to bring the 6y to the left hand side. So we will write subtracting 6y from both the sides. Here it will be 6y minus 6y, get eliminated. Here it will be 8y minus 6y plus 5. We will get 2y plus 5 in the next step. Here 31. Now subtracting 5 from both the sides, the way we have done here. 2y plus 5 minus 5 equal to 31 minus 5. 2y equal to 26. Dividing both the sides by 2, we get y equal to 13, the way we have done here. Now we have been writing formal steps here. The later part you will see this type of formal steps are not there. And one more thing, these two, instead of writing these two, we will straight away bring this plus minus 4 to the other side as minus. That you will be able to understand there. These two questions are from the textbook only, but I have included in my video because there is some difficulty in doing these sums. The first one, 28p minus 36 equal to 98. Adding 36 to both the sides, you will get 98 plus 36 on the right hand side, 134. Dividing both the sides by 28, we get 134 upon 28, that is 67 upon 14. Now we write this one. 14p minus 19 will be 14 into, in the place of p we substitute 67 upon 14. 14 and 14 get eliminated. You will be left with 67 minus 19 equal to 48. Now the next part. 28p minus 38 equal to 28 into, here instead of writing this, I am writing this so that the 28 get cancelled easily. So 28 into 134 upon 28 minus 38, the 28 and 28 get cancelled. You are left with 134 minus 38 equal to 96. Now the same sum I am explaining in another way also. Here we have straight away substituted 134 upon 28, but here we will take 2 common outside from both the terms. 2 into 14p minus 19. So from here straight away we will put 48 here. So it will be 2 into 48 equal to 96. This one, 4 into m plus 6 minus 8 equal to 2m minus 4. We will open this bracket. 4m plus 24 minus 8 equal to 2m minus 4. This will become 4m plus 16 equal to 2m minus 4. This 2m we will take to the left hand side. It will become 2m equal to this plus 16 will go to the other side as minus 16. 2m equal to minus 20, m will be equal to minus of 20 upon 2 minus 10. So m will be equal to minus 10. This is a textbook example only. In the textbook, this particular sum is done in 3 different ways. I am doing it in 2 different ways and with limited steps. 28 into x plus 4 plus 300 equal to 1000. Here the bracket is open and these two are combined. It becomes 412. Now in the next step, take 412 to the other side by subtracting 412 from both the sides. You will get 28x equal to 588. When we divide both the sides by 28, you will get 588 upon 28. That will be x equal to 21. Now the other method. 28 into x plus 4 plus 300 equal to 1000. 300 you take to the other side. Now 28 into x plus 4 equal to 700. 1000 minus 300 will be 700. Now instead of opening the bracket, we can divide both the sides by 28 so that this 28 will go. You will be left with x plus 4 equal to 700 divided by 28. That will be 25. X equal to 25 minus 4, 21. Why I am explaining different methods? In the later part of this year or next year or even in your 9th or 10th classes also, you may be required to solve equations where different methods can be used depending on your mental power or caliber. Making LHS equal to RHS is the basic concept of equations. Whatever I am discussing below is for understanding only and not meant for learning it as it is. We can make the following observations for making the equality to remain in the case of equations. When a term that is added or subtracted on one side of an equation is removed from that side, its additive inverse should appear on the other side. For example, 2y plus 7 equal to 21. This becomes 2y equal to 21 minus 7. If you are removing plus 7 this side, the additive inverse of minus 7 will appear on the other side. This is what we have been doing in the three or four sums which I have explained. If one side of an equation is the product of two or more numbers or expressions and we remove one of the factors, then the other side should be divided by this factor. 2y is 2 into y. We are removing 2. Now the 2 will remain on the other side as a division. Here it is product. It will go to the other side as division. Third one, if one side of an equation is the quotient of two numbers, that is u divided by 15, or expressions, it can be a variable also, and we remove the divisor, the denominator, then the other side should be multiplied by its divisor, by this divisor. So u upon 15 equal to 6. If we are removing the 15 from here, on the other side it will be 6 into 15. I think you must have understood this, and while doing the sums also we will be exactly doing these things only. When it is a plus sign here, it will go to the other side as minus 7, When it is a product, it will go to the other side as a divisor, and if it is already a divisor, then it will go to the other side as a product. Let me tell you one more thing. In your textbook, there is a formula given. Actually, this formula is by Brahmagupta. If an equation is of, this is not an important one, I can say not at all important. Still, when it comes in the textbook, I thought of discussing it. If an equation is of the form ax plus b equal to cx plus d, the solution can be found using the formula x equal to d minus b upon a minus c. See, 2x plus 3 equal to 4x plus 5. You want to find the value of x. So 2 will be a, 3 will be b, 4 will be c, and 5 will be d. The value of x will be d minus b upon a minus c. D minus b upon a minus c. 5 minus 3 upon 2 minus 4, that will be 2 upon minus 2 minus 1. This formula is given by Brahmagupta. Another important part of this chapter is to form equations from situations given and solving them to find the unknown. Most of these sums are related to and also help us to find solutions to problems in our daily lives also. In this video, I will be discussing limited examples from your textbook. The main aim is to write limited steps while forming and solving equations. I have just given a definition here. Forming equations from various situations and solving them gives us the ability to find solutions to many problems in our lives. This is a repetition of whatever I said. Now the first sum. Ramesh and Suresh have 60 marbles with them. Ramesh has 30 more marbles than Suresh. How many marbles does each boy have? In the textbook, they have used two variables. You can do this sum using two variables, two letter numbers or one letter number, the way I have done here. Let the marble Suresh has be x. So the marbles Ramesh has will be x plus 30. And combined, both of them have got 60 only. So x plus 30 will be 60. 2x plus 30 will be 60. And 2x will be 60 minus 30. 2x equal to 30 and x will be 30 upon 2, 15. So the marble Suresh has will be equal to 15 and the marbles Ramesh has equal to x plus 30, that is 30 plus 15, 45. This is the way we have to write. I have written the minimum steps only, limited steps only. This many steps you have to definitely write to solve this particular sum. Now the next one. Two friends want to save money. Janvi starts with an initial amount of 4,000 and in addition saves 650 per month. Sunita starts with 5,050 and saves 500 per month. After how many months will they have same amount of money? Let the number of months both will save be n. Earnings of Janvi will be 4,000 plus 650 multiplied by n number of months. The same thing with Sunita, it will be the initial deposit of 5,050 plus 500 multiplied by n, 500n. But ultimately they have equal amount saved. So let us equate these two. Now the solving part comes. Bring this 500n to the left hand side and next step 4,000 will go to the other side. So ultimately 150n will be equal to 1050. N will be 1050 upon 150 equal to 7. Number of months both saved will be equal to 7. Another one. Madhuvanti wants to organize a party. She decides to buy snacks for the party from the chaat shop in town. Each plate of snacks costs rupees 25. The shop charges an additional fixed amount of rupees 50 to deliver the snacks to Madhuvanti's house. So let us work out the answer. Total money Madhuvanti had equal to rupees 500. Delivery charges rupees 50. So after subtracting 50 from this, the money left with her will be rupees 450. And the cost of each plate of snacks will be 25. And there are five family members. Let us start the equations from here. Let the number of friends she can invite be x. Here 25 multiplied by x plus 5. X is the number of friends she can invite and 5 is the family members. So x plus 5 are the total people to be invited. Multiplied by the cost per plate, that is 25, will give you this. So we are dividing both the sides by 25. So here only x plus 5 will remain, and this will be 450 divided by 25, 18. X will be 18 minus 5, 13. So the number of friends she can invite, 13. I have written limited steps. That is the reason why I have included here in my video. These two questions form part of your textbook. Somewhere or the other you will find these two questions, these type of questions. Here, write 4 equations whose solution is u equal to 6. You can expect in your examination. So what we are doing, for getting the value of u to be equal to 6 as the final answer, we can do this type of things. The first, u plus 8 equal to 14. What will happen? When you take 8 to the other side, 14 minus 8 will be 6. The other one, 2u minus 5 equal to 7. When you take minus 5 to the other side, it will become 12. So 2u equal to 12 and u will be 6. Another one, 3u minus 1 equal to 17. When minus 1 goes to the other side, this will become 18. 3u equal to 18, u will be 18 upon 3, 6. And the last one, u plus 2 equal to 8. U will be 8 minus 2, 6. So this way you can form hundreds of answers. And the other one, frame an equation that has no solution. No solution means x should not be there. X plus 3 equal to x plus 5. So when the x goes to the other side, it will be x minus x 0. Or the x will get cancelled from both the sides. So you cannot have a solution for this. Another one here also, the 2x and 2x. Whatever be the constant value, you will not be able to get a solution to these equations. So this is the end of my present video. Once again, I request you to subscribe to my channel and tell others also to do so. More subscribers means more enthusiasm in me to produce more videos for the welfare of the student community. Please do subscribe.